The greenhouse effect PhET simulation of Group 4. Introduction. The Earth's surface is heated through the visible light that comes from the sun, which emits infrared photons. These infrared photons escape into space, but some make several round trips between the ground and the atmosphere before they depart. Along the way, a lot of energy is transferred to the ground and the atmosphere. That energy becomes heat, which warms the Earth's surface and its atmosphere. The greenhouse gases are gases that causes the greenhouse effect. So these gases are water vapor, which is known to be the most abundant greenhouse gas in the atmosphere, carbon dioxide, methane, nitrous oxide, industrial gases, which is caused by human activities such as sulfur hexafluoride, hydrofluorocarbons, perfluorocarbons, and chlorofluorocarbons. Atmospheric thermodynamics deals with the study of heat-to-work transformations that occurs in the Earth's atmosphere. Here are the different fundamental concepts and empirical formulas that provides a means of calculating and understanding the equilibrium state of atmospheric processes. Ideal gas law is an equation of state that describes the relationship among pressure, temperature, and density of any material. The particular gas constant depends on the molecular weight. Heat and temperature is both related to the internal kinetic energy of air molecules. Conduction is the process of heat transfer from molecule to molecule. And radiation is a heat transfer by the emission of electromagnetic waves which carry energy away from the emitting object. And adiabatic process often occurs when air rises or descends and is an important process in the atmosphere.
Learning objectives. In the end of this activity, students will be able to, number 1, describe the effect of greenhouse gases on visible and infrared photons as well as the temperature. Number 2, compare the effect of greenhouse gases to the effect of glass panes to the photons and temperature. And number 3, determine which greenhouse gases react to visible and infrared photons.
The materials needed in this activity. Number 1, the laptop, of course, and then the PhET simulation software. The flowchart diagram. So in this activity, there are 3 flowchart diagrams, which is the greenhouse effect, greenhouse layer, glass layers, and the photons absorption. So we need first to prepare the materials, and then in the greenhouse effect, choose the atmosphere. On the atmosphere section, choose from 4 options of time. Today, 1750, Ice Age, and adjustable concentration. And observe the kind of atmosphere that you wanted. And then select thermometer and choose between Fahrenheit or Celsius. And then adjust the greenhouse gas concentration, and lastly adjust the speed of reactions in the atmosphere. So let's go on to the glass layers. So in glass layer, you need to prepare your 2 materials, which is the laptop and the PhET simulation software. And then observe the behavior of photons. So there are 2 photons that we'll observe in these glass layers, which is the yellow photons, which is the sunlight photons, and red photons, which is the infrared photons. And then add some glass panes to observe the behavior again when you add the glass panes, and then observe the temperature changes, because in thermodynamics it is the changes of temperature. And then let's go now to the photon absorption. So you need to to prepare your materials. And on the PHET simulation, on the same PHET simulation, the greenhouse gases, select the tab for photon absorption, and then select infrared photon, then select each atmospheric gases one by one, or build an atmosphere, and then lastly observe what atmospheric gases responded to or reacted with the visible photon. So that's the end of the activity.
Now let's discuss about the simulation procedures for PhET simulation and greenhouse gases. So in the simulation, you will find three parts: the greenhouse effect, the glass layers, and the photon absorption. So starting with the greenhouse effect, there are points we need to observe, like what happens to the temperature, what will happen if there is a high concentration of greenhouse gases, and how about if there is no concentration of greenhouse gases at all? Is there any changes in the temperature? And remember that on thermodynamics, we tackle about the temperature changes and heat changes. So this simulation is perfect to demonstrate what will happen if there are changes in heat level. Also, the simulation will taught us that the cause of why our planet's temperature rises. In the simulation, you will be given choices on the kind of atmosphere, such as today, 1750 and Ice Age, which refers to the time in which that kind of atmosphere was present. So every choices have different greenhouse gas composition. Or you can just continue with the adjustable concentration, where you could just adjust the concentration of greenhouse gases in your own choice. So there is a panel where you could adjust the concentration of greenhouse gas with the use of a slider. There are also other options where you could add some clouds, and the thermometer where you could choose between Fahrenheit and Celsius. And finally, we have the legend, which shows the kinds of photons present in the simulation. So for the second part of the simulation, which is about the glass layers, this will taught us that greenhouse gases are actually like glass panes placed on the atmosphere. So the more glass panes is like the more greenhouse gases and have the same effect on the temperature. And the last part of the simulation explains what greenhouse gases absorbs and re-emits infrared radiation. So in the simulation, there are 5 kinds of gases found on the atmosphere, but only 3 of them absorbs infrared photons like CH4, CO2, and H2O, while all of them has no reaction at all for visible photons. This means that the gases which absorbs infrared photons are mostly the cause why infrared radiation was trapped, causing the change in the temperature of our planet.